do these? Alrighty, for those who think they already know how to do some of these, do you know how to construct a perpendicular bisector? Oh, Claudia? Where? On the edge. So make the endpoint is label A and B. Okay, if you take one of the pointy edges and you put it on one of the endpoints right in the center, how wide does it need to go? A little over halfway. Okay, a little over halfway. Then what do? You draw an arc. And you make sure this arc is large enough so that when you draw your second arc, they intersect twice. Now it's important to keep the same width. So once you draw this arc, don't change the width. Now you're going to pick it up carefully, not changing the width, and relocate the pointy part on endpoint B, and draw a second arc. And where they intersect is the important area, because we're going to connect those. Oh, we should get rid of that. Pass it over, pass it down. We're going to connect those two arcs intersected with a line. And when it crosses the original segment, it will be a perpendicular bisector. Okay. Okay, so carefully, precision is important in what we're doing today. Make sure you perfectly line up. Those plates with your ruler. And that they will intersect each other at a perpendicular angle. And we've also done two things. The ground is perpendicular bisector, which means we also found this point right here. And midpoint. So AC is congruent to CB, so I put those little tick marks. AC is congruent to CB. Okay? Now you know how to do perpendicular bisector, you've been reminded, we're going to construct three perpendicular bisectors on our triangle down below. It's important that you are as precise as possible because something special should happen. And if you're not very accurate, then yours isn't going to work. Okay, so as precise as possible, we're going to construct a perpendicular bisector. So by the way, with A, B, C, I'm going to start with my BC side. Whoops, that's not good. Okay, put your pointy part right on C. Make sure you spread out your compass so it's at least halfway, if not a little more would be good. Oops, there we go. And draw an arc. And you want to do this lightly because we're going to be doing lots of arcs, so you'll want to erase the arc so it gets a little too busy. Carefully pick up your compass, not changing the width. Relocate the pointy end to endpoint B over the CB. And draw an arc so it crosses twice. What if the arcs don't intersect? What should I do? What should I do? No, we just go back and fix it. Keeping the width the same. You just line it up. And oops. I just changed my width. And fix it. There we go. Okay. Now with your ruler, connect them all the way through. Oops, from here. No, don't do that. I haven't had time with this board today. Now precision is important. So do your best to line this up perfectly at the intersection point. Now, if you want, you can erase the arcs. Because we're going to draw 6 arcs in total. We get kind of busy. Don't erase the line segment. You can erase the arcs. So I'm going to take this one off. And take this one off. Okay, we're doing it again. So just found, put your 90-degree angle in. Also, note that is congruent to that. Okay, I'm going to do a C now. My compass is already on C. I need to make sure I'm more than halfway. I got an arc. Keeping the compass width the same, carefully pick it up and move it over to A, vertex A, and draw another arc so that it intersects that first arc twice. I'm doing AC right now, yep. And then take a ruler, and again, precision is important. Looking for something special, so make sure you are very careful. I'm going to move mine over just a little bit. That's good. Okay, and draw all the way through. And if you want, you can erase the arcs, because we have to do 2 more arcs. And leave all the arcs, and then get busy really quick, and it'll be kind of messy. I need to make this smaller. 200. That's going to be better for me. And now we have to do, oops, I should mark my 90-degree perpendicular angle. I should mark that that is now congruent to this segment. And we need to now go on the perpendicular bisector to the smaller side, AB. And we need to connect this one, this perpendicular bisector. Keep drawing the perpendicular bisector all the way through. All the way through. We have perpendicular angle, and this segment is now congruent to this segment. Okay, did you mark all 3 90-degree angles and the congruent segments you got? Let's see, what side are you trying to do? That side? You notice an interesting thing that happens with all 3 of my perpendicular bisectors. What happened? What happened to all 3 of the perpendicular bisectors? All 3 should have intersected, right? If you drew them precisely, they all should intersect. Sometimes, depending on what type of triangle you have, they intersect inside the triangle. Other times they intersect outside the triangle. This is an example of outside the triangle. That has a special name. Does anyone know the name? No. It's called the circumcenter, or, circumcenter. Circumcenter. You've now found the point of a circle, which, if we extended out to, can I do a dash line? Out to each vertex C, that is creates your radius. And to B, that's an equal radius. And to A, all three of those distances are congruent. So if I took my compass and put the start point on my circumcenter and extend it out to one of the vertices, ready to be amazed? Watch what happens. Extend it out to one of the vertices. Oh, failure. Let go. Shoot. We were all going to be amazed that I messed it up. So annoying. That's where the triangle is in relationship to the circle. It's inside, so it's called circumscribed. The circle is circumscribed around the triangle. And look at each vertex. Is A to, we'll call this point P, maybe. Is A to P the radius? Yes. Is B to P the radius? And is P to C the radius? Yeah, so we found the circumcenter to which we can circumscribe a circle around a triangle where the circle only touches the triangle in three perfect places at each of the vertices. Okay? So, vocabulary word. You should have circumcenter written on your paper. And write, if you would please. I don't know how to get rid of that. The circle is circumscribed around the triangle. The circle is circumscribed around the triangle. Two vocabulary words that you might not be familiar with. Circumcenter is that point we found where the perpendicular bisectors intersect each other. And circumscribe. The triangle is inside the circle. And the circle only touches the triangle 3 times at each vertex. Okay, when you're ready, let's go over to the next page. We're going to do a different one. Angle bisectors. So just do a perpendicular bisector. Does anyone remember how to do an angle bisector? How do you construct an angle bisector? It's not quite the same thing. Who knew the strategy how to do it? Sammy, do you know? Wait. Let me think how to strike out. Quickly, what? Wait. Okay, we need an arc. But the point at P, and how many times does it have to intersect the angle? Twice. Okay? It intersects twice. Now keeping that same width is important, because I'm going to pick it up and randomly relocate the pointing part to. Intersection point, so maybe N and Q. So to pick it up, keeping the same width is important, and relocate it to N. And inside my angle, I'm going to draw another arc using that same width. And Q, pick it up, move it over to Q, and inside my angle, those two arcs should intersect, and that will be the angle bisector. Take your ruler carefully and line up with P through perfectly where they intersect. We get two congruent angles, so we need to mark them. This angle is congruent to this angle. So I'll do an arc with a little tick mark so it's not to be confused with the other arcs we drew. Yes? I don't know. I haven't done that one before. Maybe. Because these should both be equal distance from that and that, so we have some more triangles on this. Okay, let's label our triangle below. I need 3 letters without the letter C or the letter O. I say without the letter O. But 3 letters, anyone? Without, but I don't want to see it. L, M, N. Now L, do it curly, so it's going to look like a 1. M and N. I actually made a bad example. We should probably capitalize these. Okay, we're going to find the angle bisectors of each. Let's start with L. Oops, that is not my compass. Okay, bring your compass over. Put your sharp pointing point on vertice L. And bring in, you don't really have to do this arc very large, but don't do it too teeny either. Make your first arc so that it intersects the both sides of the angle. So there's 2 intersections. Then you lift up your compass and relocate it to each of those intersections, and inside the angle, draw an arc using the same distance on your compass. So you're not changing the width. And then I pick it up and put it on this one. Make sure you're being very precise. Like so. And then connect them. You don't have a working compass? Anything more? These are probably crappy ones. And then connect it very carefully and draw that line all the way through. This one might be okay. I'll probably push down as it is. There we go. Okay, I would bet glue this one really tight. Or those ones. Those are the best of the ones for me. Okay, connect it all the way through from L. Oops, that's not what I want. All the way through that intersection. Move this a little bit. And then we do it again. Let's do M as in mother. Put your sharp point on M. Oops. Take your compass and intersect M twice. Using that same width. You're going to pick it up. Oh, shoot, I moved my lip. You're going to pick it up and relocate it to one of those intersections. Draw an arc on the inside of the triangle. Pick it up again to the other intersection and draw your third arc, mine are blue this time, so that the arcs intersect. When the last 2 arcs intersect, you're going to connect that intersection to the vertex M. And make sure you draw perfectly through those if you can. One more to do. Then do N. For those who have finished, you see an interesting relationship that happens. Oops, I just moved something. What's happening? They all intersect, all three of them, so we can expect this one to across or another to across. Okay, get my arc. Whoops, stop changing the size because that's not good. Pick it up. Arc in the middle. Pick it up. Intersecting arc. And connect them. And keep going all the way through. And is everyone getting them intersecting? Cool. Now, if you need to, you can erase all of those arcs, really busy. I think I'm going to choose to at least erase these ones. Okay, and where they intersect is a different point than the circumcenter. Okay, does anyone know what this one's called? This one's called the in-center. This point here is called the in-center. Infinite angle bisectors touches the triangle twice. On the vertex and across. Right here, between L and N. Right here, between L and N. And right here, between N and N. But what happens if I take my compass? Come on, compass, move. And let's call this guy I, in-center. I don't like that color. It's not showing up. That color's not good either. Can you see the yellow? I put my compass right there and connect it to one of those points. Get right on there perfectly. And draw a full circle. I think mine is off just a little bit. There we go. I like the first one better. And precision was an issue. Okay, let's try again. Okay, what happens on the circle and the triangle? The circle touches the triangle in specifically three points of angle bisectors, which meant that this segment right here, we found a radius. This segment right here, we found a radius. This segment right here, we found a radius. All three of those are congruent. Where would you put a tick mark? Okay, and we have congruent angles. There. 1, 2, 3, 1, 2, 3, because we found the angle bisector. Okay, so the in-center is the vocabulary for where these intersect. The in-center is in-center is the center of the circle. The circle is not this time circumscribed. Circumscribed is going around the outside. This time it's inside. The circle is inside. That's called inscribed. The in-center is the center of the inside circle. Circumscribed means our circle is going on the outside, touching the triangle in 3 places. Okay, inscribed means the circle is inside, touching the triangle. Okay, let's flip it over. We should already know how to find the midpoint because we found the midpoint really differently with bisectors, right? Bisecting is cut right in the middle. And on each triangle, we find the midpoint of each side. It means this part is congruent to that part. This part is congruent to that part. And this part is congruent to that part. We have 3 sets of congruent pieces. We're talking about a mid-segment this year. What is a mid-segment? What? Did you say what a mid-segment was? Mid. That's connecting the mid-point. The segment connecting the mid-point. So this is the midpoint. If this is the midpoint, the segment connecting them is called a mid-segment. And if this is the midpoint, we get 2 more mid-segments. So midpoint is the point right in the middle of the segment. Mid-segment joins 2 midpoints. And then a new vocabulary is median. Okay, the median is a segment whose endpoints, a segment whose endpoints are a vertex and the midpoint of the opposite side. A segment whose endpoints are the vertex and the midpoint of the opposite side. A segment whose endpoints are the vertex and the midpoint of the opposite side. Okay, so the triangle below I have 3 vertices. We just move by the midpoints, and we're going to connect the midpoint to the opposite side, and that's a median. Okay, I need 3 letters. X, Y, Z. So creative. X, Y, Z. So we can. Okay, let's find the midpoint between X and Y so we can connect it to Z. So, I need my compass tool. There we go. How do we find the midpoint again? We did this on the very first construction. How do we find a midpoint? On the X. Okay. A little bit more than halfway. And draw an arc. Then what? What? Keep the same width. Relocate it to Y. And this arc should intersect twice. Oh, looks like I didn't make my arc big enough on the first one. Okay, now just know if you're ruler, you don't need to draw a line. I'm going to draw a line because I don't have a ruler on my smartboard. Draw's not a line. Let's try a line tool. But just line up your ruler, and all you have to do is make a little tick mark where they actually intersect. That's the point we need. But mine's not very, I'm going to do it on the smartboard. You can't be as precise. Go away. Right there. Okay? This rest of it. Because we're busy pretty fast. Delete. 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 And delete. Now we need to find the midpoint between y and z. So do the same thing. Go a little more than halfway. Draw an arc. Make sure that it's big enough this time that I'm actually going to cross it. Keeping the same width. Woo! Dang it. Sorry. That changes things if I move the picture. Relocate it to y. Ooh. The midpoint is between the two, so line up your ruler. And all we need is the midpoint, and you can erase the arcs. Okay, one more between x and z. Line up your ruler. Okay, if there's R impact midpoints, you should notate the congruent segments on the triangle. One, double click, double, triple. To show the actual midpoints. If I want any midpoints. So this one you just need to make a little longer. Looks like this one just need to be a little longer as well. Okay, take a road from there to there and mark where it intersects. Okay, now we're going to take each mid-segment or midpoint and connect it to the opposite vertex. So, which vertex should I connect this point to? Right here. Which vertex should I connect it to? So that's the definition of median, midpoint. It needs to be opposite side. So I should connect it to Z. So with your ruler, this line you're actually going to draw. Carefully. Whoa! Dang it. Not that. Can't move it. We need to keep it there. Okay. Now from there to Z. And do the same with the other ones. This point down here, I'm going to connect up to Y. And then the last remaining midpoint, I'm going to connect over to X. Oh, interesting. Does it all intersect at a central point? Yeah. So the first one, when we connected all three perpendicular bisectors, that was called a circumcenter. Then when we connected all of the angle bisectors, we got an incenter. And this one is called the centroid. This point is actually pretty cool. This is called the centroid of a triangle. The reason it's pretty cool is because, say this was a triangle of wood, we found the centroid, we could put our finger underneath that point on the centroid, and that's the point that it will balance. Okay, so it's also called the center of gravity. So that's the point where the weight is evenly distributed, and it would balance on our finger. So it's also called the center of gravity. Another relationship that happens is we have, let's see, we're going to need some more letters here. I need three more letters. A, because we already have C here for the center. A, Q, and R. Those are our mid points. Okay, but I'm just with this. An interesting thing happens from, that's a little too thick. From Y to C. From Y to C. Is that half the distance of the whole segment Y to R? No, it's about more than half, right? Can you take a guess at what portion of the whole segment Y to R, Y to C is? 2/3 is exactly right. So, underneath, we're going to say YR is 2/3. Oops. Yeah, it's supposed to be YC and then YR. YC is 2/3 of YR. Take YR and find 66.6% of it, right? 2/3 is the distance Y to C, which means the other distance from here to here is what portion of the whole? 1/3. Okay, so CR is 1/3 of the whole YR. If this guy in yellow is 2/3 and this guy in purple is 1/3, that means the yellow one has what relationship to the purple one? Yeah, say that louder, please. That's twice the size, twice as long. So YC is twice of CR. You need two CRs to be equal. This happens everywhere. So I'm going to pick some different colors. Q to C. Is that the shorter part of that full segment or the longer part of the full segment? The shorter part, so it belongs here in this area. QC is what relationship from Q to X? So 1/3 the length of Q to X versus, that was that one. I'll do green now. Versus X to C, C to X. That's the longer segment. So what's the relationship to the whole segment? This guy is 1/3, so this guy has to be 2/3. So X to C, or CX maybe a better way to say that, is 2/3 of X to Q. And that longer segment again is twice the length of QC. So XC, you would need two QCs for them to be congruent. It's double, which means QC is half. Okay, without having to draw the other one, which one is 2/3 of A to B? C to B. Yep. This one is 2/3. is 1/3 A to Z. A to C. Or this part. Okay? And that blue part, which is AC, you need 2 of them to match the length of C to Z. Okay? Next time we'll do work problems with the math of that, of solving for missing sides. We have one more relationship, I think, on the back to construct. We don't have any homework off of this today. Your homework is just the dilations, okay? Altitude. What does an altitude mean? That's another word. I think it's synonym for altitude. What? The height. So altitude in the triangle is we're looking for the height of the triangle. Now, depending on how the triangle is rotated, you're looking at different altitudes. So the altitude of a triangle is the perpendicular segment from a vertex of the triangle, perpendicular segment from a vertex of the triangle to the line containing the opposite side. To the line containing the opposite side. Is the perpendicular segment from a vertex of the triangle to the line containing the opposite side. Okay? The vertex is a point, and the line containing on the opposite side is a line. So we know how to construct a perpendicular altitude given that we have a segment and any random free-floating point. Okay, if I pick, it doesn't even have to be in the middle, it can be over here, point K. We need to jump in altitude. Altitudes and bases are always perpendicular to each other. So you want to know how to draw an altitude? This is a new one. Okay, and we need our compass and a ruler still. And we're going to put our pointy end on the K. And then we need to draw an arc so that it crosses the segment twice. Now it's okay if you actually miss the segment because you can just extend it. You can take a ruler. Maybe I can extend it. It's not letting me extend. And just extend. And now it crosses twice. Okay? Because sometimes with triangles, the altitude's on the outside of the triangle, and sometimes it's on the inside of the triangle. Sometimes you have to extend. Okay? So take that, it should intersect twice. Okay, and then we're going to use that same width, relocate it over to one of the intersection points, and do a similar thing that we've done before. Oh, yeah, change the width. Okay, that worked. And draw an arc. And I hope I didn't just change the width again. Go over to the other intersection point. And draw an intersecting arc. We just need the base. So you can see if we do the top, it's going to go right through that point K. Connect the bottom intersection off to point K, and they should intersect at a 90-degree angle. It doesn't mean we bisected AB, we just found an altitude. A to K to Z is an altitude. That's the shortest distance for that segment, is a 90-degree perpendicular intersection. Okay, I need to try at least one altitude on the triangle at the bottom, and then we'll probably have to clean up. So after you've done one altitude, three, I want to keep this so I can text you by some more of the same height. Bring your rulers, your calculators, and your compasses up when you're done with one more altitude. So, let's do next time is the word problems, that's yellow on similarity triangles, and the green packet that is on triangles as well. And next I want to answer questions on dilations. Is anyone confused on what you should have prepared on Tuesday and then what's due on Thursday? Okay. After you've done one altitude, clean up your supplies up here.